4 is called multiple representations of quadratic relations, and reporting category 4 includes conic sections and different things about quadratics. So first thing, conic section. The definition of a conic section is the intersection of a plane and a cone. And we create, excuse me, we can create 4 different conic sections. So hyperbola is the first one we're going to look at. A hyperbola can open left and right or up and down. And I'm not going to write down the equations that go with these because they're on your formula chart and I know you have them. A parabola, when we do parabolas, we solve for y and graph. We don't use the formula in our formula chart as much. Remember that parabolas can open up, open down, or left and right. An ellipse can either be that way or like that. If we go back up to a hyperbola, the one that opens left and right uses the equation that has the x first. The one that opens up and down uses the equation that has the y first. And an ellipse is the same thing. The one that opens this way uses the x first. This one that opens the other way is y first. And a circle, with the circle and all the others, there is a center. Remember that we use the center of h and k. And with a circle, it also has a radius. And remember, radius is the distance from the center to the outside. Vertex form is for a quadratic. And it's where we use y equals a x minus h squared plus k. And your vertex is h and k. That is vertex form. Now, we usually think about vertex form along with transformations at the same time, moving left and right and up and down. Standard form, again, is a quadratic. And it's y equals ax squared plus bx plus c. And so, in order A, B, and C, we usually use standard form when we factor and when we do quadratic formula. Transformations, those are the left and right, up and down, left and right and up and down movements that we do. Remember that left is adding, right is subtracting, and up and down, up is adding, down is subtracting. So now our questions. So question number 1, which figure best describes the graph of this function? And this function's not on your paper, so you need to write it down. 9x squared plus 4y squared minus 18x plus 24y plus 9 equals 0. Now, to tell which conic section it is, the first thing you want to look at is x squared and y squared. Are they both squared? Yes, we have x squared and we have y squared. So that knocks out parabola. The next thing we look at is, are they being added or are they being subtracted? And in this case, they're being added. So that knocks out hyperbola, because hyperbola has them being subtracted. Now, the next thing we look at to tell whether it's a circle or ellipse is, are they being multiplied by the same number? We've got a 9 with the x squared and a 4 with the y squared, so that's not the same. So that makes it be an ellipse. If it was the same, then it would have been a circle. But because it's not the same, it's an ellipse. So question number 2 if the quadratic functions are graphed, which one is the narrowest? And you have those same graphs, you have the graph A, B, C, and D on your paper. What you don't have is which is the narrowest. So there's a couple of ways you can do this. You can, if you have your graphing calculator, you can put them in there and look at the graphs and see which ones are the narrowest. And so that's x squared, 1/2 x squared, 2x squared, and 1/4 x squared. So is it the fraction that makes it skinnier, or is it the whole number that makes it skinnier? And if you're not sure, you can use an online tool to use the graphing calculator, or if you have an iPhone, there's an iPhone app, or if you have a graphing calculator, you can put it in there. But I'm going to tell you that the skinniest one is graph C. The bigger the A value, and A is that number in front, the bigger the A value, the narrower the graph. Because that is a stretch, that is a vertical stretch, and so you're pulling it really, really skinny. So the bigger that number, the narrower the graph. Remember that we don't look at the negative that might be there. You look at just the number that's there, not the negative part of it. Number 3, rewrite x squared minus 6x plus 18 in vertex form. So what I need to do is look at this and find the vertex. And to find the vertex, we can use a formula. That formula is negative b over 2a. That is the x value of the vertex. So I look up here, my b is negative 6, so negative 6 means 6 over 2a, so 2 times 1 is 3. The x value of my vertex is 3. To find the y value of my vertex, I take that 3 and I plug it in. So 3 squared minus 6 times 3 plus 18. 3 squared is 9 minus 18 plus 18. Those cancel and you get 9. So 3, 9 is your vertex. So this 3, 9, that point is right 3 and up 9 on your graph. But if I go to the right, does that mean I'm adding 3 or does that mean I'm subtracting 3? That means I'm subtracting 3. And then this up 9 has to be answer choice B. So this negative b over 2a formula helps us find the vertex. If you can't remember negative b over 2a and you have a calculator, you could plug both of these in to y equals and see which one is the same. So you could plug that problem into y1, plug a into y2, and see if they're the same graph. And if they are, it's your answer. If it's not, then it's not your answer. Okay? Then you could do the same thing with b, c, and d. So that's another way to do that. So number 4. Number 4, you're not actually missing any information for it. You have the whole problem there. Number 4 says a plane cuts parallel to one side of a cone. What shape is formed by this intersection? So I'm going to draw a cone. So I'm going to cut it parallel to a side. So I'm going to cut it parallel to that side. So I'm going to cut it right there. When I do that cut, what am I left with? What shape does that make? What conic does that make? And it makes a parabola. Number 5, what is the equation of the ellipse shown after it's translated 5 units to the left and 3 units up? So I'm going to try to get that zoomed in there a little bit more for you so you can draw that ellipse. So this is our ellipse. It has endpoints of negative 1, 1, 2, 2, 5, 1, and 2, 0. And it has a center of 2, 1. So sketch that graph on your paper quickly, or pause the video. And if we're going to translate it 5 units to the left, I'm going to take this 2, 1. That center is what gets translated. So it's going to be 1, 2, 3, 4, 5 to the left and 3 units up. 1, 2, 3. My center is going to be over here now. And so that point looks like it's negative 3, 4. That's my new center. So now I'm writing the equation of that ellipse. So that ellipse is laying sideways, so x goes first. So it's x plus 3 squared plus y minus 4 squared and equals 1. But I need denominators for both of those. And I can get those denominators by looking at my original graph. Underneath the x, I count the distance from the center to the right. And from the center to the right, 3, but then I square that, so I get 9. Under the y, I look for the center to the bottom of the ellipse, and that's 1, and 1 squared is 1. That's the equation of my new ellipse. Now, where it asks for the domain and the range, I didn't specify the new one or the old one. They don't have the same domain and range. So I'm going to rewrite that domain and range as the old graph. Let's do domain and range of the old graph, the original. And the reason I'm doing that is because our graph is not big enough to graph that whole new ellipse and be able to see it all. And I'd really like you to be able to see the whole thing to do the domain and range. So let's do domain of the old one. The old one, the domain for the x's goes from negative 1 to 5. So negative 1 to 5. The range of the old one goes from 0 to 2. And if we want to do the new one, let's look at that old one. The old one goes from negative 1 to 5, and it's being moved to the left. So if the x value is at negative 1 and it moves left 5, that means it's now at negative 6. Does that make sense to you? Think about that. If it was at negative 1, left 5 means that now it's at negative 6. The old domain was at 5, and if it moves left 5, now it's at 0. The range, the old range was at 0, and it moved 3 units up, so now it's at 3. And if it was at 2 and it moved 3 units up, it's now at 5. And if that's hard for you to visualize, get a piece of graph paper out and draw that whole new ellipse, and you'll see it. Okay?